Hello mate and welcome back to Let's Code Season 6. In the last episode we created our entity class and we added some functions or methods to our game room class, which allowed us to be able to find out what is going on in any particular square and also to move an entity from one space to another. Now there's some other things that I would like our room class to be able to return. For example, I would like to be able to just get a simple list of any adjacent squares in a particular space. Now we have this method here called getEmptySpaces, which returns the list of empty cells around a certain space. So this functionality will be similar to that, except now I want to return a list of all of the items that are within the interactable space of a certain square, and if there is nothing, then the empty space will just return nothing. So that's what we're going to do the first thing this episode. So we're just going to go to tab space there, and we will just call this get adjacent. We'll just call it get adjacent because there's no real descriptive thing there, and we obviously need to use this on the instance of our room class. And I'm just going to take in a position as our only argument. Nice and simple. Now remembering the next thing we need to do is we need to check the spaces above, below, to the left and to the right. But we have to be a little bit careful here, and this is something that I didn't address in the previous episode. And that is the possibility that we might be on the left or right or top or bottom edges of the room, which means that we may get index out of bounds issues, which we will have to remedy. So we're going to kind of put that on the back burner for now. So we're just going to kind of carry on with writing the core of the source code here, and then we'll do the error handling in a bit. Okay, so all we're going to do is we're going to create a list of well, an empty list first. So we'll just call this temp list equals that, and then we're going to say x equals position 0, y equals position 1, just to make it more readable for us. So we're actually going to annotate this now so that we don't forget to. So we'll just say method to return a list of items in the interactable cells of a given position. There we go. Temp list and x and y from the given position. Happy days. Okay. Add some white space at the bottom of that so we've got some room to work with. Okay. So all we're going to do is we're going to append the list with whatever is in the section of our position in our cells. Now we could do a check like we have done here. We've done if the position is not 0, then we can add it to the list. That would be fine. In fact, it's probably a smart thing to do. So what we can do is grab this lot of code here. I will grab all of this and we'll pop it at the bottom there. Now we obviously need to change where it says list of possible cells to say temp list. We'll grab that there, paste that there, paste that there, and that there. Okay, so now this should do room.getMatrix. So we're actually already in the room, so we can just change this where it says room to self. Because we're already in the correct room, like so. I think that's basically everything we need to do. Yeah, and we can actually change this to up here as well. We can say self. Don't know why we didn't do this before. It worked, but we might as well make it correct. There we go. So now that's checking the right thing. It's checking the instance of the room class that we have referred to, and it's done the same thing down here. So we're going to save that. So now we've got a method in our room class that will return a list of all of the items that are within the up, down, left and right positions of a given position in our grid. Now you might be wondering why that's useful. Well, it's going to be incredibly useful for many reasons. Firstly, we want every single entity in our game up here in our entity class. We want every single entity within our game to be able to tell whether or not we have the player within an interactable range. So if it's an enemy, then it needs to know what's close to me, because if it's the player, then it's not going to move, it's going to attack. Okay, so that's quite important. And obviously the player needs to know what objects are interactable to it, so that if it's an item that can be picked up, it can interact with that, or if it's an enemy that can be attacked, then it can do that as well. So this method itself is actually pretty dang useful. So we'll definitely be making a lot of use of that. Now obviously there is something else that we have to do here, because what we've actually done is literally copied the code from here. So what we have to do is, in this case, we have to change what we're appending to our list. So we're going to copy that and we're going to replace the code that we have in there. So we're actually replacing the position that what we were adding to the list in our previous method up here. We're actually now putting the contents of what is in that cell rather than the cell number or the cell position. So we just copy and paste all of these things into the relevant place, like so, and then remembering to save our code again. So our new method shows very clearly that we are checking the position. If it's not 0, then we're adding whatever is in that position to our temporary list, or at least we would be if we were carrying out the correct Boolean check. As you can see, our Boolean operator at the moment is saying if the position in the matrix is 0. So what we actually need to do is say if it's not equal to 0, then we'll add it to the list, and then we will get a list of things, hopefully. So the next thing I want to talk about is creating a map, because we're getting to the stage where in order for our room class to be able to do more stuff, like putting entries and exits and things in there, we need to actually be able to tell it where it is on the map. And we also need to make some other decisions. For example, we could have our rooms built by an algorithm that builds a maze. So we could have our map set up like a maze, which is not the worst idea in the world, but that's a little bit advanced, a little bit outside the scope of this tutorial. I use a good map building or good maze building algorithm in Deeper, and it's not overly complicated, but I think for the purposes of what we're trying to create here, it's a bit too much. We could also have a setup that allows us to define, even if two rooms are adjacent, is there an entry or an exit? That would allow us to get the most out of the space. So for example, in the case of a 9x9 grid, if you had two adjacent rooms, you'd only have 9 times 9, so you'd have 81 rooms that can all be accessed very easily. Whereas if you only had doors going to certain rooms from each room, that would mean that the player has to move perhaps much longer routes to actually get where it wants to go. So that is another possibility. Failing that, the easy option is to just have the map fill a grid full of rooms, and if two rooms are adjacent, there's automatically an entrance between the two of them, which I feel like is probably the best place for us to start at the moment, simply for simplicity. Now, if you remember, if we go back to our game room at the very top here, we can see that we've got a room type and an exit variable, which are things that are going to allow us to determine whether or not we have exits, or room type determines what the room's going to look like. It might be an internal room or an external room or whatever. So when we create a room, we need to determine what these two values are, which is not too complicated, but we need to define or decide how we're actually going to create our map, because our map needs to be something that we can save and that we can open again and that we can manipulate. So if we wanted to put a map editor into our code later on, then we could do that as well. So what we're going to do to create our map files is we're actually going to use Microsoft Excel or any other version of database software that allows us to export as CSV. CSV stands for comma separated value. Okay, and here's an example of a CSV here. We've got just a bunch of zeros separated by commas. And if we look at what that looks like in an Excel file in a minute, then we'll be able to see that that's essentially all we're going to need. Now, in order for us to make this work, we have to make some changes. The first thing that I've done on the left here is I've created a data folder. And within that data folder, I've put in an empty file called map.csv, and we'll fill that file with information in a bit. We've also had to add some more script to our map class. So if you open your map class, you'll notice that now I've created an init method. And inside that init method, I've said that the map file is basically we're going to, when we create our map instance, we only provide one value, which is a map file, and then the code will then say, right, so your map file value is equal to the Ren'Py's loading of that map file. So Ren'Py will load the file that we specify in this bit here, and it will save it in our class as its map file. Okay, and then once we've actually loaded the file in, we can pass that information to actually determine what it means. But for now, we need to do that. So if you remember, in the game class, when we create our map, we now need to input the data/map.csv as our property for creating that, and that will then run same as it did before, because at the moment all we're doing is we're loading the file and we're not actually doing anything about it. So what we can see I've done here is I have created a 10 by 10 matrix just full of zeros at the moment, and this is going to be the map file that we're going to pass. And then once we've figured out how to pass this file into our game map, and then we can start adding some data to this map that we can then turn into rooms, which I've started implementing here in our map class file, as you can see. So I'm going to annotate this code as I explain it to you. So the first line is just the start of our initialization. This is our constructor if you were programming in another language. And it only takes one argument, which is the name of the map file, which we've already discussed. And then our first line is where we actually save the file into our class. So I'll just put... And we have to make sure that we encode it as UTF-8, otherwise it's going to end up coming in as binary, and then we won't be able to do half of the functions that we've done here. Okay, then what we're going to do is read each line like this. So we're saying that this lines is going to become a list of all of the lines within our file. So if we come back to map, each one of these lines will be read into a separate value within this list. So we're creating a list of all of the lines within, and we're using read.splitlines because we want it to strip off the new line marker at the end of each line. I know I've said lines about a million times in this last 30 seconds, but there you go. So we're removing that so that we just get a nice clean list, a nice clean string in each entry in our list. So read each line and strip the new line marker. Then we're setting up a temporary variable, or it's actually going to be a temporary index, so that when we go into our while loop, we have everything we need. Now, we don't actually have to use a while loop here. I've actually made this unnecessarily complicated, so let's remove this. What I'm actually going to do is I'm going to use a for loop instead. So instead of using while list, we're going to say for line in lines, and now we've got our line. We're going to say temp list. We don't need this anymore, but we will do anyway. Temp list equals line dot split. There we go. So now we're saying the temp list. We're now creating a list from our line by splitting our line by using the comma as our separator, and then we're adding that list to a temporary matrix which we've created here. So we'll just annotate that. which is our 2-dimensional array. So it's a list of lists. So each entry in our list will be full with another list. In this case, it'll be the list of the variables or the values within our comma separated value list. I'm getting my tongue all tied so we can remove current line from that one. And that's a lot more elegant. So we'll now just say loop through the list of lines and split. No, we'll move that. We'll have that being here. So we'll say split the line into individual values, moving commas. So we're basically passing a CSV, and now we're going to add the temp list to the temp matrix. And now, for the sake of being able to see and test and so on, what we've done is we've actually just said that self._matrix is a temp matrix. Now, that's not going to be like that forever, because we want our temporary matrix to have rooms in it and nothing else. But for the purposes of just testing our code and making sure everything is working fine, we have this this setup as it is now. And in order to test that it's actually read in the file correctly, we're going to just test it here. So I'm going to type in print game dot, no, that's all capitals, game dot, I've got to remember now, I think it's game map dot underscore matrix. And there we go. As you can see, every entry in our matrix, which is 10 lines long, has a 0 in it. So we've now passed in our comma separated value file into our matrix like that. Now we can pass this matrix through a series of checks, which will allow us to create rooms based on what data we actually input into our CSV file. I feel like we've covered quite a bit in this video already, so we'll go into parsing this data in the next video so that we're only doing this in small bite-sized chunks. Thanks very much for watching that, guys. I hope you found it useful. Let me know what you think in the comments below, and I will see you in the next one. But until then, you take damn good care of yourselves, alright? Bye-bye.